Hello and welcome to AWS Repost Live, the companion live stream to Repost.aws, where we dive deep into questions and use cases of our AWS Repost community. Today, we're talking about Amazon SQS, answering questions and diving in deep with some demos. I'm Stephen Heverin, your host for today. I'm joined by Nadesh and Tom from AWS. Nadesh, go ahead and introduce yourself.
Hi everyone, my name is Nidesh. I'm a senior cloud support engineer based out of Bangalore, India. I mainly work on serverless and Kubernetes applications.
Cool. Tom.
Hi, this is Tom. I'm from DFW Dallas area in United States. So I'm mostly working with SQS, MQs, and also like all those like developer mobile service day-to-day lives.
Awesome. Thanks for being here. Before we begin, in chat, let us know where you're joining us from today. Not already on Repost, head over to repost.aws after the show and sign up with your AWS account ID or your builder ID and join us and take part in our conversation over there on Repost. Take our brief survey also in chat there. Let us know how you're doing, what you want to see on the show. So today we're covering questions around Amazon SQS from our Repost community. In case people may not be aware, Tom, why don't we start with what SQS is and the problem that it solves?
Sure. So a lot of the customers that we see day to day is working with like microservices, and a key feature that requires to work on the microservices is to have a way to have messaging queues so that they can transfer messages and data across all those components. And SQS is our Amazon solution to allow the message queuings across the components. We have like a high reliability. We auto scale based on your usage, and we also offer first in first out capabilities and also encryptions.
Cool. All right. With that intro, we've got our first question here, and it comes from a Repost user 815. They've got SQS with a high volume of traffic. What's the starting time for calculating the visibility timeout? And they've got a lot of traffic here, and it looks like they're kind of having to restrict their queue to avoid being throttled. And they have a few questions kind of about understanding the visibility timeout. How long should they set that for, and kind of what is the impact, along with a couple other things here that they get into. And we do have a really good answer and some links to some articles here posted by a couple of our experts in the community, Didier, Oleski, and Gary, two of which we've had on our show before. But I think, Nadesh, Tom, we've got some more information here that we can provide and talk about.
Sure. So this is actually a great question and a great question to start with how SQS works. So in terms of SQS, we have two roles. One of which is called producers. This role is a client, typically a client or like an application where you send message into the queue. And then on the other side, you have consumers, which is the one that are receiving the messages. This part is where the visibility timeouts comes into place. So as a great answer from Didier's mentioned here, that when you start with the receive message request, this is where you start the timer or a clock on the visibility timeout. From this time on, within the visibility timeout period, you should be you should consume your message and then call delete message calls so that it can be out of the queue. Otherwise, the message will be there and then will be reserved essentially to the consumer side, and all the other consumers will not be able to see the message on the queue. But once visibility timeout expires, if you do not delete the message, it will go back to the queue, and from that moment, everyone else can receive the message again. So this is how visibility timeout works, and why you should delete the message within the visibility timeout so that you can successfully continue consuming messages rather than seeing the message over and over again.
Gotcha. And so it's kind of like your own. I'm thinking of it as kind of like your own personal little post office here, right? That you're handling these messages, but you take them private to do something with them. But if you don't do it within that period of time, it goes back out. Something else can pick it back up and try to do it again, and manage it that way. Great answer. Anything else with kind of what they've outlined here in the question from that Repost user, or anything else that we want to kind of dive into about, like, they talked about throttling and something like that. I guess how, kind of what's that impact of that long poll, or changing that timeout and that visibility kind of in terms of how you're being able to process and handle all these messages in a high volume of traffic.
So great. So essentially, what you have here, usually speaking, like in order to save your time, similar like you have your personal mailbox, you are not calling for like checking back your mailbox like second after second. So you have like long poll mechanisms where your consumers will send a request to the server and to ask the server to say, hey, within that 20 seconds, for example, tell me if there's any new message or if there are any message exists. If that's the case, return it back. So this essentially is a long polling second. However, the long poll doesn't is different than the visibility timeout, because when you do visibility timeout, it's been only started after you receive the message. Essentially, it's only when you have returned your response from the receive message API calls.
Got it. If you're just joining us, we're talking about SQS today and questions from our repost community. Let us know in chat. Are you using SQS today? What are the use cases that you've got, or what are your questions about SQS? We've got the experts here, so please feel free, drop your comments, drop your questions in there. Let us know, and we'll try and answer them here on the show as we're going along. So that's a great start, great information, Tom. I think with that, are we ready to move on to one of our next questions, or from there?
Sure.
All right. So we got another question, this time from Alan, and they want to know why their SQS messages are moving to DLQ, which I know enough of to say it's the dead letter queue, without being delivered to Lambda. So he's encountered this issue where they're triggering an SQS is supposed to trigger a Lambda function to handle those messages, right, that are coming in. And instead, it's moving everything right to the dead letter queue. So they're trying to troubleshoot it. And he's got a lot of great detail in here with what he's kind of already gone through, how he's configured some of these things, including some of the screenshots, which is fantastic. Giving you a lot of detail here about this. And we even had the AWS repost agent chime in and provide a lot of really good information in response to this, which one of our experts, Gary, again, has managed to take a look at and verify that the response given here by the repost agent is pretty on point. But I think we can add some more information around to this.
Cool. So usually, so this is introducing to another concept we call dead letter queue. So as you correctly point out, this is where the messages we call dead letter are resizing. So why we have this concept? It's because sometimes your producer can send the messages that are not like able to be processed by a consumer. Maybe it has some errors, or it sent a message incorrectly or unexpectedly, and then on the consumer side, you also do not want to. You also don't know like how to process this. This is why we have like a maximum receive count, where you can determine to see how much time that we gave for each of the individual messages for them to receive, process, and if they are not able to process, they will be returned back to the queue and tried again, and to determine like how much time they can go into dead letter queues.
And with this, so we've got Jeb George thrown in that he thinks it's Lambda permission issues. So what is the problem here that this user is facing?
So actually, we do have a demo, and George, thank you for posting that. That's a good question. We will have a demo about this just a moment, but let me just finish the concept here, so that in case some of the audience here might not be not so familiar with dead letter queues. So one thing that we see usually in terms of Lambda, there are as greatly like pointed out by our repost answers, as long as Gary. So there are a lot of cases, for example, like when you maybe you like configure your visibility timeout to be too low, or for example, in one of the situations where your Lambda has like not enough concurrency to process the message, and you are seeing Lambda getting throttled. And also, we also can see sometimes where we have permission issues where the Lambda is not able to process the messages, and because of that, it will stay in flight and then come back to the queue. With that said, we do have like prepared for 2 demos on this in regard to this question. And Nidesh, can we first show them about like what happens when Lambda function gets throttled, and in this case, like what's the matrix look like?
Sure. Now I'm going to show that demo, the first demo that I have. Now on the screen, we have a SQS queue. I'm just going to run by a few configuration, and then I'm going to share this, the setup that we have, along with how we can actually find out what the issue is. Now, if you look at this, we have a queue. The name is Lambda throttle scenario 1, and just a default SQS queue as encryption.
And I like it, Nidesh, you're naming things the way I name things in my environment.
That's good. If there is a Lambda trigger, now there's a Lambda associated. Now I've just associated with a Lambda throttle scenario, just giving it, just associating with a Lambda function. And I also have this dead letter queue, which is configured with a max receives of 2. And so like Tom mentioned, if messages goes beyond the max receive, then the message goes into the dead letter queue. Now I have this scenario wherein I sent a message and the message just landed into this DLQ. I want to find out what happened. Now, the first step, can anyone tell me what you would do to figure out why the message went into the dead letter queue? What would you check?
Yeah, let us know, audience, in the chat there. What do you think? If you've got this problem, it's going right to the dead letter queue. Where are you going to look first? Where would you look first in here as we're going along? And let's see what our audience says as we kind of dive in here some more. So yeah, go ahead. Yep. So
okay.
Sam 9010 says the Lambda monitoring tab failed invocation.
Okay, that's good.
And next up, the checking the Lambda logs. Yeah,
that's good. Yeah, that's good. That's the right direction. That's good. Awesome. So here again, SQS is again integrated with CloudWatch metrics. We're just going to run by a few CloudWatch metrics before we check into Lambda to see what SQS metric shows. Now we have a bunch of metrics. What we're going to focus is we're going to focus on a few of the messages or a few of the metrics. Now, for example, I can see that
now here you're starting versus in the Lambda side of things. You're starting here on the SQS metrics, right?
Yes.
This is where we're starting. Let's take a look at the metrics. And
yes.
I always like looking at the graphs first myself to
True.
look at the visual stuff before having to dig into logs, because I don't like having to go through logs. So.
Yeah, that's a pain. I mean, if you have like a lot of logs, it's a pain to go through them. So metrics is, I think, the first place to start off with. That helps in diving deeper. Now, if you look at this, I've actually sent a message at 1910 UTC, and I've seen that message received, which is nothing but the consumer received the message, and it kind of indicates that there were 2. And what I noticed is there were no messages deleted. Okay, so which means I have the messages sent. The messages are not deleted. And if you look at the number of messages visible, which indicates how many messages are available in the queue, which also indicates a 0. So it seems like the message was sent to the queue, but was not deleted. But now, what could have been done, or what just happened? Now, what I have is I have this dead letter queue, which is again a different queue, which is configured as a dead letter queue for the original queue. Now, looking at the metrics of the dead letter queue, what I notice is I see that the number of messages available is a number of messages visible is 1, which means the messages is in the dead letter queue. Now, the way you can confirm is if you look at the send metric, there's 0. So which means there was no producer pushing the message, And if there is a message indication, then it is very likely that it was moved from the original queue to the dead letter queue. Now we have established that message was moved from the source queue to the dead letter queue. Now we need to understand why the message moved into the dead letter queue. Right?
So just to kind of clarify there, like following along, right? You've got your SQS queue that's processing the messages, or should be processing the messages in this case, and it's not. It's going right into from there. It's going over to the dead letter queue, which is in and of itself another SQS queue, effectively, right?
Correct. Yes.
So it's just a special kind of queue that it's moved into. So, and again, like the number of messages, like a message is deleted, that's different than going into the dead letter queue, right? It's those are two separate things. Like if the message processes and deleted, it doesn't go to the dead letter queue, right? It's just
correct.
Okay.
That's right. Now, in an ideal scenario, what will happen is if I send a message, there'll be a number of messages send metric. If the consumer received the message, then there'll be a metric for number of messages received. And if the consumer deletes the message, there'll be a number of messages delete. That's how the ideal scenario is. In our case,
consumer is going to be should be the Lambda in this case, right?
Yes, consumer is the Lambda in this case. Now, in our case, we didn't see any delete calls, but we see the messages landing into the dead letter queue. Now, let's figure out why or what happens. What is our Lambda function doing? Now, this is a Lambda function that's configured to the SQS. Now, what I have is it's a simple Lambda function that actually prints the records, nothing much. And the Lambda and the SQS integration works in such a way that if Lambda is able to poll the message and process it, then it automatically deletes the message. That's how the Lambda SQS integration works. Now, let's look at the metrics of Lambda to see if we can find something. Now, if you remember, we sent a message at 1910, so we should probably see something. I'm looking at invocations, which is nothing but how many times a Lambda was invoked. I see 0. Duration, nothing. Error count, nothing. This kind of indicates that Lambda was not invoked. Now, let's see if there are any other metrics that can help us find.
And I can tell you, I've gone to my Lambdas, and when I've seen nothing in there, I'm like, I know I called this Lambda. Why is nothing happening? So help me figure this one out, Nadesh.
Yeah. So now I'm looking at throttles. I see a lot of throttles. Now, there are no other metrics except for throttles. Now, what's happening is whenever a message is sent to SQS, there's a Lambda poller that actually polls the message and tries to invoke the Lambda. And in this case, the Lambda was throttled. Now, it retried. It retried multiple times, and then when the count of the message that was received was greater than 2, what happened is the message moved into the dead letter queue. So essentially, the Lambda was not invoked because it was getting throttled, and because the receive count, the receive count was greater than 2, the message was moved into the dead letter queue, and that's what happened in this case.
And all right, so I think you're about to reveal what the issue might be.
Correct.
Before we do that, so we've got Sam 9010 and Arun Kumar, both we're saying permissions issues. And I think Sam's getting on to how much is the concurrency set for this Lambda. So I think Sam's on to where we're heading with this.
That's right. So if it's a permission issue, you will see you'll be able to see a little different issue. But if you look at the configuration, and if I'm looking at the concurrency, I've set it to 0, which means the Lambda will never be invoked. Now, in a production scenario, you won't set it as 0, but there might be scenarios wherein you might set it to a lower value, and due to the lower concurrency of the Lambda function, the messages might move into the dead letter queue.
Right. I mean, and you could, if you're doing a deployment, if you've got something, a configuration wrong with the Lambda, you could accidentally set the concurrency to 0. Yeah. I mean, I just know me as a developer, and I know I'd probably do something like that. So, clearly you don't. If why have a Lambda if you are never going to use it, right?
That's true. Now, I just have a working setup just to show you what I have. So here again a Lambda trigger with just a suffix working to indicate, to differentiate those two setup. And I have this Lambda. So I have this monitoring. I'll just check out the monitoring to see what's happening. So similarly, I just sent a message at 1910, and then I see it was received at 1910, and then it was deleted. So this is actually what ideally it should have been done. And if you look at this is my Lambda function. Again, it does the same process. I'm just going to check the configuration to see what is the concurrency. So I haven't set any concurrency, so it uses the account level concurrency. So it's able to process the message.
And problem solved, change that concurrency, and we're able to move on with it processing messages. But I guess to touch on what our audience was taking a stab at with the permissions issues, if it was a permissions issue, you mentioned you would see a different type of error, right? So if I'm looking at the monitoring and stuff here for the SQS, would I see it there? Would I likely see something more on the Lambda side of things to indicate that it might be failing the call because it doesn't have the right permissions?
True. And one more thing you can always go check is the permissions. So if you go to the permission, you have the execution role, and here you can actually see what permissions I have. Now here I have receive message, delete message, get queue attributes. So these permissions are there for the Lambda role. So the Lambda role will be able to probably receive the message and delete the message.
Cool.
Awesome.
Thank you, Nitish, for showing this demo. So we do have like point or touch on the fact that permission can also take a toll in terms of why can message get not received and go into data queue. So with that said, one of the things SQS allows, and as we always do strive for, is security and safety of the data in terms of when you use of the AWS ecosystems. One of the features we have is called encryption, and this will align with how the permission will go in terms of your consumer. So right now we have a great demo. We will show a demo about like how, like, if you have a consumer, assume that's a Lambda that has insufficient permission, what will happen and what will cause in terms of matrix look like that can cause a Lambda or a message to go into data queue. So Nitish, take the screen.
Yes, thank you.
And if you're just joining us here on AWS Repost Live, we're answering questions from the repost.aws users around Amazon SQS and some of the problems and troubleshootings you've got with that. So yeah, Nadesh, you've got another demo here in the same vein, troubleshooting this in this scenario.
True. Now, if you look at this is a second scenario that we're going to cover related to KMS. Now, just want to highlight a few things about this queue configuration. If you look at this encryption, it is a key management service key, which means it's a custom managed key. That means any messages that is sent to SQS is going to be encrypted by the custom managed key that is specified. Now, again, I have a Lambda trigger, which was named by SQS Lambda Custom KMS Scenario 2. And I don't have a dead letter queue here. I just have alias or the encryption, the KMS key that's being used for the SQS messages. Now, I have this scenario wherein...
and the again, Lambda in this case has got the right amount of concurrency, right?
Yes, I can probably confirm that. So this is my Lambda. I'm going to show you right there. Yeah, I haven't set any concurrency, so it's going to use the function, the account level concurrency. Now, again, just going through the code. Again, it's just printing the message body and nothing else. Now, what I've done is I've actually sent a message to the queue, and what I notice is the Lambda is not getting invoked and Lambda is not processing the message. Now, going back to the metrics, I'm just going to see what I and
I was going to say, yeah, we see a lot different kind of metrics here on this queue compared to the last queue that we saw, where we didn't really see any activity at all.
Yeah, true. Now, this is because, again, I just sent one message, but if you look at this, there are different metrics. The first one is the oldest message, approximate age of oldest message, which indicates how, the age of the oldest message that is in the queue. Now, if I send message at 1910, and if it stayed for so long, then it's going to calculate the difference between the current time and when the message was sent and calculate the age of it. And that's how this metric is getting populated. Now, again, a number of messages delayed is nothing but if I send a message with SQS as a feature that you can send messages with a delay parameter. And if I have that delay parameter set, then this metrics get populated. Approximate number of messages not visible, it's the number of messages in flight, which is nothing but the number of messages that are consumed by the consumer but not deleted. So it's kind of like in flight, which kind of indicates that it's with the consumer. Now, approximate number of messages visible is nothing but the number of messages that is available for the consumer to poll.
Right, which would be the inverse of what
in flight is.
Yeah, in flight. Yeah, the opposite of that, ideally.
Correct. Now, empty receives. Now, if you have a poller and it kind of polls the queue, if it gets an empty receive, for example, I don't have any messages in the queue and I just poll the queue, then
so
it's considered as
here the Lambda is polling, but it's saying you're giving me nothing.
Correct. Yeah, I don't see any. I didn't get any messages. I don't have any messages. SQS do not have any messages. Now, messages deleted, like I mentioned, it's the number of messages that are deleted from the queue. Messages received, it's the number of messages that the consumer polls and gets
Something back.
Yes, and the number of messages sent is the producer that is actually sending messages to the queue, and the message size is nothing but the message size of the message that was being sent. Now, if you look at the metrics, I send a message. I send a message at, again, 1914, and I go to Lambda, and again, Lambda has metrics, and I don't see any invocation in Lambda.
So now we're not seeing anything. We don't have anything, and it's just going right. And we know we're getting stuff in the dead letter queue. So, audience, help us out. What do you think? Where do you think you look next to figure out what is going on with this scenario?
So we can also confirm there are no throttles.
And Sam9010 says status says disabled, I think, under the target.
That's true. That's true. But why would you can think of why would it get disabled?
Well, we've got one of our other users, trigger may not be enabled or configured properly, right? Maybe it's not making the call correctly.
Okay, and it probably think a little more on the grounds of the queue is encrypted queue. So any thoughts on that?
Well, I'm going to guess, because you gave me some pretty big hints on this one, and Karupia is with me on this encryption, that maybe it's not able. Maybe the Lambda, JibJab06, maybe we're back to a permissions issue. And I think maybe they're right that I'm going to go with the permissions issue with, is it maybe the Lambda? Now everybody's chiming in the permission issue.
That's right.
But where would that permissions issue be? For I think it's going to be related to the encryption and related to KMS, and Rolex IMC is with me on this one as well with KMS. So what's Nidesh, let's not keep the audience in suspense. What's the answer that we're looking for?
It is related to KMS, and the way we can check is we have CloudTrail. Now CloudTrail has this information about who what API calls are being made and who makes this call. And what I do is I just went there and checked for decrypt. Now, if you see the decrypt call, I see access denied. And what I notice is it's actually the Lambda function that's actually making this call of decrypt. Now, whenever a Lambda is actually polling the message, it's necessary for the Lambda to have the decrypt permissions on the KMS. If it doesn't have, then the messages will be in flight and the Lambda won't be invoked. Now, if you let's look at the Lambda for role permissions. Now, if you look at this, it has SQS permissions, it has CloudWatch permissions. That's all, nothing else. So when I add a KMS permissions, this Lambda will be able to pull that message or pull that message from the queue and process it. That's how it works. Now, just to show you, like, I mean, the working setup, I have another working setup wherein I have this configured correctly. So if you look at this, I have this Lambda, I have this queue, which is again configured to a Lambda function. Now, looking at the Lambda function, what you can see is you can see invocations for the messages that were sent. And if you look at the configuration, the permissions, it has the KMS key permissions. So if it has permissions, then you'll be able to see, one, you'll be able to see CloudTrail logs. If it has permission issues, you'll be able to see CloudTrail logs, and you'll also not see any metrics on the Lambda effort.
Right. So in this case, you would go right and maybe search for this, right? Maybe, okay, if it's not, I might think maybe I need to search for KMS messages or Lambda messages and kind of dig in a little bit more with the logs to understand where that might be. And what I like here too is that you've minimized those permissions, right? It's only what it needs. It just needs to decrypt this key. That's it. It doesn't need to do any encryption. It doesn't need access broad to anything else, which I like to see, that it's just that. So here you add it in and it starts working again. So back, you had, I think it was Sam had mentioned before, he had noted that the previous example, the queue was disabled or was disabled there. And I think that might have been a bit of a mistake. That's more, I think, was that just to keep it from pulling away?
Correct. Yes.
Yeah.
So what happens is after a certain time, the Lambda function just disables the trigger so that it doesn't, because anyways, this is not going to solve on its own. There is some effort involved to fix this issue. So this, it automatically disables.
Right. So it's gonna after a period of time, it's like, look, I clearly can't do anything. I'm giving up. I'm stopping. I'm not gonna keep banging my head against the wall and moving forward. And obviously, some of this you'd want to be able to have alerts and monitors and things raised so that if something stops working, you'd want to be able to get an alert or something on that, right?
True. That's absolutely right. So you can have metrics. I mean, you can have alarms on the SQS metrics itself to see how many messages sent, how many messages received, deleted, to see if there are no messages deleted, then there's something wrong with the consumer. You can probably check what's wrong with the consumer by looking at metrics and CloudTrail logs.
Awesome. So we've covered a couple scenarios here as from the question that we got from a repost user, Alan, about why the SQS messages might not be moving to the dead letter queue without being delivered to Lambda. So Alan, thanks for that question. Really appreciate that. And thanks to the audience here. I love all the guesses. Love jumping in here with helping out to try and track down what the problems were. All right, so we got another question to go here in chat, right? In the list here of things. So now we're moving on to a question from user OU. Amazon SQS FIFO queue with multi-threaded consumer and ensuring per order message group ID is the question. So he's got this Spring Boot Java application, and what he wants to do here is making sure that the first FIFO queue being first in, first out, right? If I remember my terminology correctly, right? That it maintains the order of the messages with the same message group ID. So it seems like he's got these different messages coming in that are grouped together, and he wants to maintain the orders of that specific group of messages here. And he's kind of concerned about how he can kind of keep that here in place, and ensure that order, because he's got to process these things in a specific order.
Okay, yeah. So, thank you, OU, for posing this question. So now we touch a concept called FIFO queues. So SQS offers two essential type of queues. One is called standard queues, and the other is FIFO queues. So normally we see some of the systems which requires a strictly first in first out order, and this is why we introduce FIFO queues just for this purpose. Now, to ensure that we have like first in first out sequential order, what we do is to have like a message group. Think of like message group as your lanes, and then you can have like multiple message groups, which is essentially labeled by message group IDs, and to become into one queue. So think of the queue as a row of the message group as a lane. So that's why you can have concurrencies where you say, like, for example, a process of orders, like you can go each order with the sequential and also have multiple order process at the same time. With that said, yes. So for FIFO queues, when you receive the message, you can have multiple like messages coming from different message groups. This is where like we are expecting the consumer application that your developer designs for here should be able to have expected for like concurrencies if you have like multiple message groups that you send from the producer side, as well as when you have like, for example, in this case, all you mentioned here, the multi-threaded consumers, where you want to make sure is you want to make sure that each of the thread should be considered as a consumer, so that you won't be able to you won't necessarily go into the deep rabbit hole where you have like a lot of you have to figure out which one is coming first and which one is coming next. But fortunately, in terms of the FIFO queues, we do have like a way that you can like tell whether the message is coming first or not when you send a message into the queue. So when you do a send message request, and also irrespectively for the receive message request, you have called sequence number. This is unique in terms of FIFO queues. By introducing the sequence number, what you can tell is when you receive a message, you can tell if the message is coming before or after in terms of one message group. So that if you do have this type of situations where you have multi-threaded consumers, you can then use the sequence number to tell like whether I received the message first, did the message coming actually in the first of the message group or at the lower, like in the later part of the message group.
Gotcha with that. And so with this one, we also have as well a couple of other answers here, which I think covers some of what you had talked about, Tom, from a couple of our experts, Yuri Oleski and Giovanni, as well on this, and some follow-up, I think, from OU on kind of getting that clarification there. So that's a nice deep dive into that with those queues. We've got I say rather long question from Kangoro, interested in knowing they've got this, they want to kind of generate 1 million QR codes, 1 million rows. So they want to basically be able to kind of process this and be able to parallelize this with Lambda and SQS, or is it better maybe with something else? Is the scenario that Kangoro puts out here something that is what a use case SQS would fit for?
Sure. So that's actually a great question. So, so in terms of the capacity we have, SQS does offer like it's a similar way you can use send S3 events into the Lambda functions, where Lambda can process each of the rows, because the first thing you want to do is to split out those rows so that you can generate each one of them individually on your Lambda functions. And once you have that, you can send this into, for example, to another different Lambda function just for each rows as a message, and then to process in a second Lambda function to generate the the QR code that you have, and then from there on the second Lambda function to the process deliver to S3 by the send files or the APIs to deliver to the S3s. And if you want to have a zip file capacity, you can do that as well in the Lambda. Essentially, Lambda will be the great way to do that. You can also do as an ECS. It's really up to you, like how frequent you want to do that. If you want to do that, for example, on demand, then maybe Lambda can save you some time because Lambda is like called by on demand. On ECS side, you have to manage your ECS workers, and then it can be charged based on runtime as well. So that can be one concern that you might to design for.
Right. If you have to kind of run this process every so often, my inclination too would be to lean towards Lambda for that use case, unless there's something that, in terms of processing this, and if you're talking about handling QR codes, definitely I think something that could fit into the window with Lambda. So Kanguro, thanks for the question out there. If anybody else has any other questions, feel free to throw them in chat. We'll kind of solution here on the fly. And help you out. You still have to finish coding the solution, but we'll give you some ideas there with that. And I think we had a couple more demos around some of the scenario. Back to the other question with the queues that we wanted to cover. Is that right, Tom?
Yes. So one thing that we earlier mentioned is, and also chat, let's keep engaged. So like we also have multiple different ways that you can go into the, you can have a message and expect it go to the data queue. So one thing that we also want to talk about since the last demo we showed is about permissions. We want to talk briefly about KMS encryptions. And I see a lot of experts here talking about KMS as well. So in terms of KMS, and with the combination of SQS here, what we do is called envelope encryptions. In terms of envelope encryption, what we do here is to have like a main key, which is the KMS key, to generate a data key. And from the generated data key, we use that key to encrypt the actual message. This way, we can save the network cost, so you don't have to send the entire message into the KMS service just for it to encrypt it. And also, we can encrypt files larger than 4 kilobytes. So SQS by default comes with 256 kilobytes of message size. That's how we can do that. And when you do decryptions, first you do is to get your KMS key to decrypt what you have the data keys. From the data key, you can use that to decrypt your actual message and then to process from there. That's why we have like different permission requirements in terms of sending the message with the KMS encrypted queue and receiving the message from the KMS encrypted queue. Now, Nidish just also showed us like how to do that on the consumer side. We have 2 demos about how to send message from a service perspective and also from a normal client's perspective.
Right, because the SQS examples right there were SQS handling and encrypting the messages it's got, right? But here, I also want to be able to make sure the messages get there encrypted. I want to be able to make sure stuff is secure and encrypted all the way through that entire cycle, right?
Mm-hmm.
Cool.
That's
so I think
right.
Nidesh, you've got
Yes.
the demo controls
I'm
here.
going to show the demo. Yes.
So let's bring that up. If you're just joining us here, we're diving deep into questions from the repost user community on SQS, and let's and going on with some demos here.
Got it. Now, on your screen, you'll see a topic, which is the SNS topic. Now, SNS is a service that has this PubSub model, wherein you can have a fan-out architecture, wherein if you send one message, the messages get fanned out to a different set of consumers. Now, on those same lines, I have this topic, which has a subscription. Now, the subscription can be SQS, Firehose, or HTTP endpoint. Those are the sample endpoints that can be subscribed. In this case, I have a queue.
Can you bump that up one level for me? I got old eyes here, so
yeah.
I don't know about anybody else. There we go.
This should be good.
Much better. Yeah.
Okay. Awesome. Now, like I mentioned, you can have a SQS endpoint or a Firehose endpoint. In this case, we have an SQS endpoint. So what essentially it does is, if I publish a message to SNS topic, the message is going to get forwarded to SQS queue. Now let's look at the SQS configuration. Now, SQS configuration, again, if you look at this, there's no delta queue. I just have encryption enabled, which means it's a custom managed key encrypted queue. And let's just look at what the encryption is.
And I guess
encryption key.
you touched on this. Obviously, you're just doing this for a demo with not having a dead letter queue. But I guess, is there scenarios where people would want to not have a dead letter queue for SQS, or is it probably going to be good practice that you still want to have that?
It's good practice because there are chances in the code that the application might not be able to handle a particular message. Maybe we'll never know. So it's always good to have that so that you can inspect that message later.
Gotcha. Cool.
But in certain cases, it's not recommended. One of the use case could be like if you have a certain set of commands, like in that should be executed in a FIFO order, then if the message is going to the dead letter queue, then the next sequence of steps is going to get disturbed. So
Gotcha.
In that case, it's not recommended. So if you have that FIFO logic, then it's not recommended. But if you have the messages that's not going to be dependent on that FIFO logic, then you can always have.
Gotcha.
Now, I have this CM custom managed key alias as SNS SQS custom scenario 3. Let's look at the queue policy just once. So this queue policy allows SNS service and with the topic that I just mentioned to send message to SQS. Now, what I see is when I send a message to the topic, ideally the message should be forwarded to the queue. In my case, what I see is the messages actually don't land into the queue. Now, the way I see is I go check the metrics. Ideally, I should be able to see, because SNS is sending the message to the queue, we should be able to see a number of messages sent because that's the producer metrics. Now,
Right.
I don't see any messages. Any idea where I can look for now?
And
now,
again, we turn to the audience. Come on, throw your
Yes.
answers out there. Let us know where you think we should be looking, or what do you think the problem might be here in this scenario. And so this is, and while we're giving people a chance to think about this and throw in some answers there, at J Bush 90 says ask Q. That's a great suggestion. I love that. And Kangoro is suggesting maybe it's the Q policy or the SNS policy. And so what do we think's going on here, Nadesh?
So we checked the queue policy. We saw that SNS is allowing the queue the topic to the queue SQS is allowing the SNS topic to send messages. Let's just jump into the SNS metrics as well. So SNS has this metrics, number of messages published and number of messages failed. Now, if you look at the SNS metrics, we see that a message was published and a message was failed, and a message failed to deliver. Now, SNS has this great ability or a great feature that has integration with CloudWatch logs. So for every message that you send to SNS, it can log if the message was success or a failure. And
right.
In my case, I've actually enabled the logs. Now, I was able to just pull up one of the logs. And if you look at this, if you look at the error again, it's KMS. Now, KMS is, if you remember, we had this SQS encrypted with a custom managed key, which means the SNS service needs to have permissions to the KMS key. In this case, it doesn't have it, and that's why the message failed to get delivered.
And we've got Sam and Sid SSN both chiming in with it being a permissions issue. So I think we were on it, and I like that highlighting there. Access denied exception right there. Big red letters. Can't miss it.
Yes. Now, how do we add permissions for a service? In this case, SNS actually doesn't use a role. So the way you can actually go do it is you'll have to go to the key policy and add permissions. In my case, if you look at the key policy, it's actually it's just allowing the root. It's not allowing the SNS service. Now, I have a working setup similar to my previous examples. This is again SNS, SQS, same setup. And SQS is also encrypted with a custom managed key. And if I look at the metrics for SQS, I should be able to see a message sent, which means the message that was sent to SNS topic was forwarded to SQS. Now let's look at the permissions that was used by this KMS key. Now, if you look at the KMS key permissions, if you look at it, in this case, it allows the service SNS AmazonAWS.com, and then it allows decrypt and generate data key. Because it allows these permissions, this SNS is able to forward the message to SQS queue.
So here it's able to go ahead, get the key, and do that. And you're having, because of how SNS works, you have to allow it on the KMS side of things,
yes,
versus defining an SNS role or something else that you might define, like with Lambda or something else, right?
Yes, that's right.
And Sam's on it, the KMS resource policy, add the principal for the service, SNS, and give it that example. So great set of questions. Cool. So we're almost getting close to time. We got anything else here to demo, Nidesh or Tom, that we want to cover through in scenarios before we close out?
Sure. So as our repost offers, we have also have a type of article called knowledge center articles, and one of them we want to share about, which we earlier I have a hint about it. There are multiple ways you can see your message go into data letter queues. One of which, especially if you are first in the developing stage of your message, you will sometimes try to see is to pull the message out on the console. This is where the article also explains greatly about why that can cause the issues. So essentially, what you do here is that you will see the message. You will see the message pulling out from the console, and this can count towards your receive count. And as data queue has a policy for the max receive count, this count against that. And once you pull that enough, or if you have set it to a very low value for the max receive count, that can cause the message to go into data queue. So in short, as a takeaway, when you pull the message from the console, that is the same as you do it from the consumer side, but you will have occurred a failed receive, and that's why you can sometimes unexpectedly see your message into the data letter queues.
And this is a call out first to a great article. We have not just questions and answers here, but we've got a great knowledge center out on repost.aws with great articles written by our experts and stuff, sharing this knowledge, sharing this information out there. We've got a question from Mendel. Is it a good idea to use two different KMS keys, I assume, for the same SQS queue in production? So I think in that last scenario where you're talking about sending those messages around, should you be separating out those keys and using different keys?
Usually speaking, and also thank you for the questions. Usually speaking, like you can only set one key at a time, and when you set a key at the queue, the message will be encrypted based on that message and then get in-queued. So usually speaking, you don't want to change the KMS keys unless you feel like you want to rotate the key. Once you have a low traffic, you will stop the message from producing. Otherwise, even if you rotate your keys during the time you have like live productions, what you see is the message from earlier, which is your first key, will still get encrypted on that first key. And then essentially you can get into a situation where you are not able to decrypt it on the consumer side because you are already rotating to other keys. So that's why usually speaking, you want to stay with one, and unless you have a rotation policy where it allows you to rotate, that's where you can, once the traffic flow goes lower, and then you can do that.
Awesome. Thanks for that. Thanks, Nidesh and Tom, for being on the show today, giving us some great demos. Thanks to all of our audience members and Sam and Kangura and everybody else chiming in, helping us solve some of the problems with our SQS queues. Thanks to our repost users for their questions as well. So we dove into troubleshooting and really kind of diving into getting the most and understanding how you can use your SQS queues with Lambda and other services to really make the most of it. If you haven't, be sure to head over to repost.aws, sign up using your AWS account ID or builder ID, and start expanding your cloud knowledge today. Check in the chat for a link to our survey. Tell us how we did today, what else you would like to see us to cover on the show. And speaking of shows, join us next Tuesday, March 25th, 2 p.m. Pacific, where we'll be joined by a longtime friend of the show and Principal Tam Raj to discuss streamlining operational troubleshooting and with Amazon Q developers. So as Jay Bush, one of the suggested, use Amazon Q. So we're going to be diving into using Amazon Q Developer. Start the discussion now by heading over to our article and repost and asking your questions in the comment sections. Don't forget to click and follow AWS Repost Live while you're there for all of the updates about our upcoming shows. And don't forget to subscribe here on Twitch or other live stream channels for more AWS Repost Live and similar shows. Thanks again, Tom and Nadesh, and everybody else. Until next time, happy building.
Thank you.
Thank
Thanks,
you.
everyone.